Okay. Thanks for the invitation, and thanks for you all for being here. We're going to do a report card on Royals. I have no disclosures. I'll mention that I am on the review group that looks at the Royals events, and I am chair of the work group on Royals within APM. What we're going to do is briefly look at the Royals structure, how it's set up, and also then quickly look at how it's grown over the past 18 months of operations. We're going to concentrate mostly on what lessons have been learned, because I think that's really where the interest is, and then mention something about the changes that are coming probably in June to make the system better. How it's structured, Royals is this radiation oncology incident learning system. It was an initiative coming out of ASTRO. We at APM found out about it and offered to participate, and they were happy to have us. So it's co-sponsored by ASTRO and APM. It's supported by the board of directors financially, and I hope you all will help us to continue that. It is run through the Clarity PSO, Patient Safety Organization group based in Chicago. This is the group that ASTRO has the contract with to actually run the website and help deliver the information to us for analysis. Key things is that it's a web-based system. You don't need any specialized IT systems or IT support in order to participate. There is no charge to the users to participate. You do need to engage in a contract with Clarity. That is, your facility has to have a formal contract with Clarity, because that sets up the legal protections required under the Patient Safety Organization law that keeps the data protected by law, which is a big issue in this country. The design of the system was done jointly. The report form design was done jointly by ASTRO, APM, and Clarity. The key thing is that it can serve as the facility's only incident learning system if you don't already have one in place. When it's time to report an event, it's a two-step process, similar to the one that was mentioned earlier today from the St. Louis group, in that there's an initial report by the front-end user, which might be very brief, and then it's the opportunity for the review committee within your group, within your facility, to go in and put in additional information. And this is crucial because you want the frontline person to be able to flag, something has happened, this is my quick description of it, and then they go on with their work. And then your QA committee, or however you organize it, will go in and look at that information, do more of analysis on it, decide what is the corrective action, if any, and then you can put that into the Royal system to share that information. So this is the basic scheme of this. Something happens, you jump into the Royals Incident Reporting System, which is a web link on your computer. The initial report is done by the frontline person. Additional information will go in whenever you're ready by the review committee. And that information is sitting in the Clarity building, basically their servers, but it's in an institution-specific database. That can be identified data. Nobody's going to be able to see that except for your facility. And you can do any sort of analysis on that information that you want to. But then whatever incidents you choose can be sent up to the national database, which is de-identified. Nobody can tell from which institution it's coming from, with the exception of the folks at Clarity. But when it comes to us for review, we have no idea which institution this is coming from. And then these incidents are investigated by this review group, which is called the Radiation Oncology Health Advisory Council, wonderful name of RO-HAC. Basically, it's a group of eight professionals, physicians, physicists, dosimetrists, administrators. We look at all the incidents, try to pull out case reviews, lessons learned. That information goes out to participants in quarterly reports. So you have two ways of learning how to improve your system. One is that by looking at your own institutional specific information, and then by getting information from the national system. And these green and orange colors are significant in a minute. So what does it look like? I'm not going to try to give you all the screenshots of what the form looks like on the web, but just to give you an idea, it includes narrative descriptions of what happened, how it was discovered, what corrective actions might have been done. So there's narrative information, and there's also then data elements that have selection drop-down items that you choose. For example, this is in what workflow step was the event first discovered. Well, these are the workflow steps that come from the consensus document. But you pick one, basically, and you have a question here about in which workflow step did it happen, and in what workflow step was it discovered. And then there's a narrative question also, how is it discovered? So if you are good about filling out all this information, then the review committee can help gather useful information from it. So again, how is this information used? Well, all of the reports that are reported up to the national are reviewed by a team of 8 radiation oncology professionals. Those are MDs, physicists, therapists, dosimetrists, et cetera. It's called the RO-HAC. The information is sent to us by Clarity, and if we really want to know more about an event, which happens rarely, but occasionally, we have to go back to Clarity and ask them to contact the facility to see if it's okay if one of us can talk to them to learn about it more. We've only tried that a couple of times. But again, it's to emphasize the confidentiality of this. We don't know to whom these events are happening. And then these 8 people look through all these reports and try to glean from them the most useful findings, and those are summarized quarterly and are transmitted then to the users of ROILS. And jumping ahead to the bottom here, you can see it too, even if you don't participate in ROILS. You can go to the ASTRO website, astro.org/ROILS, click on the Reports tab, and you can see all of the quarterly reports that have come out. 6 have been sent so far. This is the status as of March 2nd of this year. ROILS went live in June of 2014. Currently, there are 98 signed contracts representing 98 practices and 203 facilities. Some practices have more than one facility involved. That's why that number is different. There are 36 pending contracts representing 67 facilities. And as of a date slightly earlier than March 2nd, there were 2,500 reports, local reports, put into the system. And as of March 2nd, there were 1,500 reports that had been uploaded to the national system. And if you just look at the growth curve of the number of facilities participating, you can see that there has been a very steady increase in the numbers since June 2014 when it first went live. And that's really quite encouraging that there's been this steady progression of growth. And if you look at the curve for the number of reports in the system, it's quite similar. It's growing substantially. How is it being used? Well, some of the users, and we're among them, we have an internal system already, so we only choose to send up a few events that we think are the most critical into the national system, the events that we think are going to be of potential interest to other people. However, other folks don't have any other system, and so they're using it as their comprehensive practice improvement system. So for example, this is something I looked at recently, this data uploaded to the national through Q4 of 2015. There were 3 facilities, each of which had put in more than 100 reports. There were 12 facilities that had put in 2 to 9 reports. So you see quite a distribution of how people are using the system, and mostly that depends on how comprehensive a system do they already have. But I think one of the things I want to emphasize here is that if you do want to use it as your own internal system, if you don't already have one, you can use it that way. So now we get to the part that I think is most valuable here, which is what have we seen that's actually interesting? What's actually useful coming out of this that could actually be a learning tool? And I mentioned that the RO-HAC group looks at all the reports and pulls out interesting findings, case reports, and puts those out into these quarterly reports. And some of this information I'm going to share with you comes from that. A lot of this comes from an analysis that I've been working on recently, where I looked at through all the reports that had come through Q4 of 2015. At that point, there were 1,296 reports, and RO-HAC when we're reviewing each of these reports, we rank them on a Likert scale 1 to 5, where 4 and 5 are the most critical. So I looked at the 232 reports, 18% of the total, that were ranked as the most critical, to see what patterns and lessons could be pulled from that. Now, of those 232, 53% reached the patient, and for me, what that means is that a therapeutic beam was initiated. There were 45% that were near misses, and 2% were general unsafe conditions. Well, that's kind of interesting, but not really terribly useful. Okay. So if you get into the detail of the narratives and you start looking at keywords and applying keywords, and this to me is the key, you've got to really get into the narratives to pull information out. What do we see? Well, if you look at how was the information caught, who actually detected the event? And here I'm classifying, differentiating between those reached the patient, R is the means that reach the patient, or either was a near miss or an unsafe condition. Of those 232, physicist review caught 30 of them. Now, it could have been pre-treatment QA, could have been weekly, could have been during the chart check, whatever, but 30 of them. RTTs reporting the event was 34 of those. IGRT, image guidance, so imaging prior to treatment, was finding problems that got reported into Royals. Most of those were near misses. Sometimes they were recognized after the fact. The incident we looked at today, for example, would have been something found by IGRT but was recognized after the fact. There were cases where chart rounds specifically were called out as being the useful technique. And again, the emphasis here, this is information you get from getting into the narratives, which you can only do if the narratives are sufficiently complete. This is really interesting to me. How were things missed? What safety barriers didn't seem to work? And when I looked through these reports, and I tried to ascertain, so in which of these events did there seem to have been an opportunity for a physicist to catch it? There were 74 of those that were missed. There were actually 104 potential catches where a physicist could have caught it, but the physicist didn't catch it in 74 of those events. So almost, basically 70% of the time. Of the events reported to Royals, okay, were not so great. There's a lot of stuff getting through, and I have some examples of that as we go on. But again, if you start looking at the narratives and details and looking at keywords, these are some examples of the kinds of events that we're seeing most commonly. Some mismatch between what the physician's intent was as described by the prescription and what the plan was. And we'll look at that in a bit more detail. That was one of the most common. Shifts, problems with shifts. Does this surprise anybody? No. But we can look at exactly more detail about which maybe gives some ideas of how we might make this better. Generalized plan quality, sometimes it's pretty clear their human data transfer was involved, probably more often than just the 14 I had there. Gating, for example. But let's look at some of these things in more detail. I think this is where the real useful information comes from. Let's look at places where there was a difference between the prescription and the plan, all right? Notice that in 18 of those that reached the patient. So in this, I said 44 initially, but here let's look at 23, where specifically you could tell from the narrative that there was an approved plan, a plan that was approved by the physician that did not actually meet the physician's intent, right? Of those, there were 4 cases in which simply the MD gave an incorrect instruction to the planner who did what was desired, and then after the fact, it was realized, oh, that's not really what I intended. Okay, we'll look at a couple examples of that. This to me is interesting. There were 12 of these situations in which what was in the treatment planning system did not match what was in the written directive, but that was unrecognized. It got approved. And this is really interesting to me. There were 7 cases in which it was either called out explicitly or pretty well clearly you can make the inference that the planner wrote the written directive for the physician to approve. But there was a problem with it that the physician didn't recognize when it was approved. Does this surprise anybody? Does this ever happen at your place? So how can we make this better? Again, this is only what's reported, right? Right. So again, interesting things you find here. The MD gave incorrect instruction. Well, one of these was where the prescription was called SBRT. This prescription was written 4 gray times 4, all right? Instead of what the physician intended actually to be 12 gray times 4. Now, in this instance, the planner and the checker did not question an SBRT prescription at only 4 gray times 4. However, a physicist doing a weekly chart check did question it, and that's how it was found. Okay? Here's another case in which there was an SBRT prescription prescribed at 5 gray times 6. The physicist checker said 6 fractions doesn't seem like it ought to be SBRT. And the physician said, oh, I meant 6 gray times 5. Okay, so here's a good catch, right? Here's not so much. It was found at the physics check, all right? But here's something, again, how cognizant are we when we do these things? This, again, opportunities for improvement. Plan did not match the prescription unrecognized at time of approval. In 12 of these cases, 7 reached the patient. 3 of them involved, there was a problem with the targets. The target was perhaps contoured, but not included in the plan, but yet the physician approved it, okay? 2 of those were not found by the physics checker. In 8 of these, there was a dose per fraction mismatch between the prescription and what was in the plan and got sent to the therapist. 7 of those were not found by the physics checker. This is pretty basic. We really ought to catch these, and yet we're not. What is this telling us? So how can we prevent these sorts of things? And can this be automated? This is where I think the information comes back to us as an opportunity for improvement, as a learning system. How can we automate checks that are comparing the prescription to the plan, or tying these together so that they can't be different? How do we actually put in systems that prevent this from happening, as well as making it easier for us to catch it when it does? So here's the case where cases in which the planner wrote the prescription for the physician to approve. There are 3 cases in which I could tell it was specifically called out, others in which it's implied. 5 involved dose per fraction. The biggest was 6 gray per fraction was intended, 2 gray per fraction was actually written. That's a big difference, and these were some other differences. 2.67 intended, 1.8 gray per fraction planned. There was another case in which a breast plan was done by a dosimetrist who thought, based on a comment in a treatment planning note, that the supraclav area was to be included in the breast plan. The physician didn't actually want that to be done, and it was found during a chart rounds. Okay, but let's look at this 6 gray issue. Patient was to receive, and this is basically mostly cut and pasted from the narrative, and this is a good narrative. This is a really helpful narrative. Patient was to receive radiation therapy to his right shoulder for painful bone metastasis. The dosimetrist received a verbal order from the radiation oncologist for a dose of 12 and 2. Now I'm going to do my best George Sorrells impersonation, which involves an intake of breath and a roll of the eyes, okay? Received a verbal order, okay? Now, the dosimetrist wrote the written directive for 6 treatments of 200 centigrade each for a total of 1,200 centigrade, 12 and 2, okay? Written directive was then approved by the rad-onc, should have been 2 treatments of 600 centigrade each, and it was found at chart rounds. The patient had already received 2 fractions of 200 centigrade each, and the rad-onc decided to give 1 additional treatment of 600 centigrade and call it a day. This is a good narrative. This tells us something that we need to pay attention to. How can we prevent this? Does it ever happen in your facility that the planner either writes or revises the written directive after they finish the plan, and then the physician approves it? Happens at our place all the time too. So, given that sometimes there's a mismatch, what kind of behavioral changes can we promote within our own departments such that if there is a mismatch, the physician's going to notice it? Don't know, but this is clearly a failure mode that we could address. IGRT failed to catch your cause. Now, these are some cuts and pastes out of the quarterly reports, which I'm really promoting that you take a look at these. Wrong vertebral body treated. This was a case in which CBCT was done, and the automatic alignment snapped to the wrong vertebral body. There was a large shift that was done, but that wasn't flagged as being an issue, and they recognized it after the fact. This was a case in which they were using cone beam CT to treat a leg, and they recognized after the fact that they were 5 centimeters off in treating that part of the leg, and the recommendation was, the bone looks all the same. How are you going to know where you're going to line up? Maybe cone beam CT isn't the best tool for doing this kind of treatment. Maybe KV-KV matching, where you can see What about shifts? We do shifts all the time, and here there were 30 cases where I could tell the shifts was an issue, 13 of which reached the patient, 17 of which were near misses. Of those 30 shift events, what I could tell from the narratives is that 9 of them had shift values transcribed incorrectly. Centimeters to millimeters, for example, is a fairly common one. Another 4 of them had shift directions transcribed incorrectly. It was supposed to be anterior, was written posterior. 6 of these were caught by physics, 13 were missed by physics, 13, not the same 13, but 13 reached the patient. Again, this is an opportunity for improvement. We ought to be able to automate this. If there's a shift called for in the plan, can we not come up with techniques that make it clear what is the magnitude of the shift and what is the direction of the shift, such that that can be brought into the treatment instructions in a way that eliminates a lot of these errors. We've got a technique that one of our physicists has come up with in our place that's based on Excel spreadsheet. There are different ways to do this. You can imagine the vendors might be able to help us with this information coming directly from the plan reports. But again, this kind of thing happens. We're seeing it happen. Royals can tell us this is happening with some frequency, but then it's up to us to figure out ways to improve it. Laterality. Most of these are near misses. Most of these are documentation slips where the correct side is being treated, but the wrong side is somewhere in the documentation. But not all, and this is one thing that I really want to emphasize. This was a really interesting, good catch that was mentioned in one of the cases. Patient's case was reviewed in weekly peer review radiosurgery SBRT conference. So in this one institution, they review these cases before the plan is done. And reviewing the diagnostic images, it appeared that the target was delineated on the wrong side. So this doesn't happen very often, but obviously it's a catastrophic problem if it does. How many of us actually have peer review of patient contours before the plan is started? This is good to see that there are that many, but most of us don't. And how can we use Royals in conjunction with Astro to get this information out to physicians, say this is important for these hypofractionated cases? Now, where are errors happening? What we're seeing is that, not surprisingly, 135 of these 232 errors were flagged as happening in treatment planning. The most where are they being found? Pre-treatment review and verification, plan checks by a physicist or a therapist, for example. 46 found there, 104 detected at treatment delivery. This is suggesting perhaps that our pre-treatment review and verifications are missing a lot of things. How can we make that better? Okay, so what lessons can we learn about RO-ILS itself? One is that patterns that we see can direct attention. They can indicate failure modes that are happening. They can indicate some idea of frequency with which they're happening. They can indicate safety barriers that are working or safety barriers that aren't working. And they can indicate opportunities for improvement. However, what we're finding is that to really get useful information, those of us doing the reviews have to study the narratives. The drop-down classifications can only get you started. You really have to study the narratives, and that takes a whole lot of time. But it works if you guys write good narratives. That's absolutely crucial. Many of the reports include narratives that are much too sparse to be of use. For example, patient was treated 3 cm to the right of the planned isocenter for 1 fraction. All right, what am I supposed to do with that? Don't know why, don't know how it's caught. Okay, useless report, doesn't help. And as more of these reports come in, it's getting to be more of a challenge for 8 of us to do this review. This is something we're trying to figure out. How can we prioritize the reports to spend the most time on? Improvements that are coming on the way. There's going to be a new version of the website rolled out probably in June. Many of the data elements are being condensed and clarified. At least one is being expanded. The basic incident type has had a couple things added, including a non-safety event type, which was mentioned today by Sam Hancock as one of the things that he saw as an issue with RO-ILS, which is true. If you want to use it as a comprehensive process improvement system, you need to be able to flag an event that's not a safety event. And so that's being added now. And very interestingly, in this new version of the website, there's an inter-rater reliability study that's been done, where 12 fictional events, one of which you saw today, were reviewed by 67 people, put into the new RO-ILS system, and then we're seeing, so how reliable, how consistent are people classifying these events? And so that analysis is currently underway, and Ezzell Kapoor is the key person behind that. The APIM working group is working on a user guide to help explain to users how to use RO-ILS, what's needed in a narrative, how to classify events, how to decide if something is a near miss or reach the patient, how to decide if it's a near miss or an unsafe condition. We've got some suggestions that are going to come out as to how to do that classification. And what I would ask if you're involved in this, if you get into it, is even if you don't really agree with how the line is drawn, if you'd use it that way, then we can be better at pulling consistent patterns out. Also, when this recorded reports are coming out now, there's a slide set template that's part of that is you can grab and use in your own QA committee discussions as the case reviews, for example, and you can ask the question, could this happen here? What are we doing to prevent this? That sort of thing. So this is our way of trying to get incident learning happening, so you get some value out of putting information into the system. And also there's a mapping process being created that if you have a sophisticated software-based incident learning system already, you'll be able to have some sort of efficient mapping so you can decide which events go into RO-ILS and not just be double duplicating the work. So if you're interested on how to begin, you go to the ASTRO website, go to ASTRO/RO-ILS, download the participation guide, review the helpful FAQs, and there's a place you can send in questions if you need it. So let's do some SAMs, and then time permitting, 5:30, we'll ask some questions. The main thing that I want to know is, how could RO-ILS be useful to you, and what do you want to see from the system? How can we make this an incident learning system, not just a reporting system? So, first question. RO-ILS, 1, requires purchasing software, requires a contract to be signed, requires AAPM membership, directly connects to your EMR, requires an annual fee. survey says. Yes, that's right. Requires a contract to be signed. And again, that's in order to set up the legal protections so that you work under the auspices of a patient safety organization. RO-ILS went live in June 2014. By February 2016, the number of reports entered was 10 to 50, 100 to 250, 500 to 750, 750 to 1,000, greater than 1,000. Yep. The first number is probably the number of facilities participating. The second number is the number of reports in the system. And the workflow step most commonly identified as the source of reported events, in which step is it happening, is the error occurring? Is it imaging for planning, imaging and simulation, treatment planning, pre-treatment QA review, or treatment? Okay, correct. Treatment planning is the most commonly reported source of errors. So, thank you very much for your attention, and I'm curious to know the answer to this question either during questions or after.